So today, we're going to look at part 2 of distribution data, more specifically, graphing of the distribution data. Once again, let me bring up standard deviation because you'll see later on how important this value is. It's how far from the mean we're talking about. So, standard deviation is 68% of your data. How much of that data is incorporated in there? And then we'll see deviation 2 and then 3. Finding the standard deviation, step 1 is we need to find the mean. So I have my data points here, 12, 15, 16, 19, 18, and 22. I'm going to add those numbers together, divide by 6. My mean is 7. The average of this data is, 17. The average of this data is 17. Then we need to find the deviation of each value, meaning I need to take each of these numbers and subtract them from my mean. So 12 minus 17, negative 5, 15 minus 17, negative 2, 16 minus 17, negative 1, and so forth. So you're finding the deviation from the mean, given each data point. Next, once you have that, note that some of our deviations are negatives. We want to square the data because that turns it positive. So my negative 5 squared is 25, 4, 1, 4, etc. Now we want to take that, all those squared deviations, add them together, and divide by the total minus 1. So n minus 1. So I have 6 data sets. Minus 1 gives me 5. All of that added together, minus 5 divided by, all that together divided by 5 equals 12. And lastly, take the square root of 12, because remember, we squared just to make it positive. So let's take the square root. Gives me 3.46. What that means is, from the mean, I am 3.46 on either side. So we said the mean was 17, correct? So let me add 3.46. That gives me 20.46. Let me subtract 3.46. That gives me, what would that be? Calculator? 17 minus 3.46 is 13.54. And what that means is, this is range is talking about 68% of my data right there, between 13.54 and 20.46. It is this much right here in the green region. We're talking about that much, the majority of my data. Okay? Let's see, have we gotten this far? Did we find the mean to be 89? Yeah. Score of 89, okay. Good, because if you had something different, everything else is wrong, right? Next, find the deviation of each value from the mean. So 98 minus 89, should have gotten a 9. 91 minus 89, 2. 82 minus 89, negative 7. 90 minus 89, 1. 87 minus 89 is a negative 2. And 86 minus 89 is a minus 3. Should have gotten that for your deviations. So far, so good. Now we square the deviations. 9 squared is 81. 2 squared is 4. Negative 7 is a 49. 1 squared is just 1. 2 is 4. And negative 3 squared is a 9. That should have been your squared deviation. So far, so good? Okay, now let's add the deviations together. I got 148 divided by n minus 1. So I have 1, 2, 3, 4, 5, 6. Minus 1 is a 5. So that's 148 divided by 5. 29.6. Are y'all with me so far? What's the last one? What's the last thing we need to do? Square root of 29.6 equals a standard deviation of 5.44. How do we do? Do we get it? Well, so we need to divide it by n minus 1. So count how many I have. 1, 2, 3, 4, 5, 6. So 6 minus 1 is 5. Next, we're going to look at something called a 5-number summary. It's basically a collection of the data we calculated yesterday. So what it consists of is your minimum, the Q1, which is your lower quartile, the median, your Q3, which is the upper quartile, and the max. And it's all that in like a nice table format. This is how it looks as a box plot. So if you have a box plot, you go backwards. You can tell where your minimum is, where your median is, what's the max value. If you're given this data, then you can actually take this data and create by hand a box plot. You can go vice versa. So I look here, calculate the 5-number summary. So I have 13, 14, 18, 1, 50, 24, and 19. First things first, what do I need to do with this data to help me? Very good, put it in order. I'm going to go ascend in order, but it doesn't matter. So there's 1, next is 13, 14, 18, 19, 24, and 50. What is my minimum value? Lowest number.
1.
So 1. What is my median?
18 and 19. No, 18.
18, right? If this is my number, I have 3 on this side and 3 on this side. So my median is 18. What is my maximum value? 50. What is my quartile 1, my lower?
13.
Very good. So you're going to take the median, look at the lower half. What is the middle, the median of the lower? 13, right? So my lower quartile is 13. And what is my quartile 3, my upper? 24. Very good. That's the median of the upper half. So I can actually take this data here and create a semi-box plot. So if I'm going for 1 to 50, I know I have a value up here, value down here. Oops. My lower quartile is at 13, so let's see, that's halfway is 25. What's between 25 and 50? Let's just say 35, and here let's just say 15. Use different color. So where my lower quartile is 13, somewhere around here. My upper quartile is at 24, so somewhere around here. My median is at 18, right here. Box that off and make that go up. Like so. There's my box plot, drawn by hand, using the data. Here's a more professional looking one. Now note, what did it do with 50? They put a dot. What do you think that dot means? From one of our terms we used yesterday.
It's an outline.
Very good. It's an outlier. We don't know how to calculate outliers yet, but I can see from the data that their 50 is way out there. So you would just use a dot as an outlier. So down the road, we'll figure out how to more correctly draw a box plot by hand. All right, you give it a shot. Calculate my 5-number summary and sketch the box plot. Okay, first thing I need to do is set these in order, right? So what's my lowest grade? 81. Then I have an 82. And then 87. 2 90s. a 91, and a 98. What is my minimum? 81. What is my median? 90. What is my maximum value? Highest grade in the test, 98. What is my lower quartile? So in the middle here, 82. What is my upper quartile? 91. So let's see. I'll draw it horizontal. We're going from a 0 to the highest score, 100. In the middle is a 50. I'll call this 75. We'll call this 90. We'll call that 60. And we should be good there. So my minimum is a 81, somewhere around here. The highest is a 98, close to 100. My lower quartile is an 82. I'll draw it here. My median is a 90. My upper, wait, was that a 90? That's a 91. 91. Complete the box, draw my line, and it should look something like that. Very rough sketch. More professionally, it'll look like that. So there's our box plot. Going into more detail, what it kind of means. Again, those dots are outliers. And that box is your IQR. Remember we calculated that yesterday? What's minus what to find it? Yeah, your upper quartile minus your lower quartile gives you that box range. So we're finding the range between the 25th and the 75th percentile. Let's see if we can interpret things with box plots. Which box plot has the smallest value? Looking at this graph. Who had the lowest value? Liberty or no-till? No-till, very good. Right here, right? Had the smallest value. Which box plot has the largest median? Liberty, very good. I see right here, greater than this value. And which box plot has the largest interquartile range? Obviously, no-till, right? Had the biggest range. A student wants to know whether Centrium vitamins dissolve faster than the corresponding generic brand. The student used vinegar as a proxy for stomach acid and measured the time in minutes it took for a vitamin to completely dissolve. The results are summarized in the box plots below. Which box plot has the largest median? Generic, right? Right here. So its median took longer than Centrium to dissolve. Which box plot has the largest interquartile range? Yeah, generic. Again. And which box plot has the smallest value? Centrium. Right here. So based on our box plots, what is your conclusion? Yeah, the student wants to know, does this Centrium dissolve faster? Did it? Yes. And in conclusion, he can say, yes, it did.